In a few previous lectures, we have tried to understand different kind of analog modulation schemes, their generation, their demodulation, that means detection, merits, demerits, the properties, the features, advantages, disadvantages, applications, etc. The last part of this analog communication is the noise. Here we will try to understand the brief description of some common type of noise. Then we will try to understand some parameters like noise figure, and then at last we will try to understand the performance of different systems that we have already studied in presence of noise, how the system reacts when along with signal some noise will appear. So let us start this noise. Now noise may be defined in an electrical sense as an unwanted form of electrical signal which tends to interfere with the proper and easy reception and reproduction of desired signals. Many disturbances of an electrical nature produce noise in receivers that modifies the signal in unwanted manner. In radio receiver, noise may produce some peculiar sound in loudspeaker output, whereas the television receiver, in television receiver it may appear as snow superimposed on the picture. So effect of noise is dependent on the type of system we are using. But thing is that whatever may be the type of system, it actually creates some disturbances in usual reception of the signal. This is the fundamental property of the noise. Now, noise may be subdivided according to type, source, effect, or relation to receiver. So various classifications may be there. But here we will try to classify the noise in terms of source. So we will try to understand from the source point of view how we can classify this noise. Source point of view. Noise may be classified. Main classification is one, external, and second one is internal. External means the noise is coming, or the noise source is external to the communication system, and internal means it is internal to the communication system. That means noise is generated within the system itself. And here for external noise, noise is actually coming from the outside of the system. External noise may be further classified into several categories. One is atmospheric noise. Second one is extra terrestrial, and third one is the industrial. So these are the, in broad sense, the classification of the external noise. Now, extraterrestrial noise may further classified into solar noise and cosmic noise. We will discuss internal noise later on. Internal noise may be partitioned into short noise, thermal noise, and there are various other noise present in the as internal noise. So we will discuss it later on. First, let us try to understand is external noise. We will discuss all these things very briefly. So first consider the atmospheric noise. This noise arises maybe from lightning discharges in thunderstorm and other electrical disturbances occurring in the atmosphere. These disturbances occur in the form of impulses, and because of their random nature, they spread over the entire radio spectrum normally used for broadcasting. Atmospheric noise thus consists of spurious radio signals with components distributed over a wide range of frequencies. These disturbances propagate in the same manner as ordinary radio waves of the same frequency. Thus, a receiver located at any point on the ground receiver and reproduces these signals along with the desired signals. These unwanted signals manifest as a variety of strange sound in the radio receivers. The atmospheric noise resulting from from natural disturbances is referred to as the static. Field strength of this noise signal is approximately inversely proportional to the frequency. As a result, this noise interferes more with the radio receivers than television. Atmospheric noise becomes less severe at frequencies above 30 megahertz. So its effect will be seen less than 30 megahertz. For greater than 30 megahertz, this atmospheric noise is very weak. And since 30 megahertz, above 30 megahertz, the frequencies above 30 megahertz are limited to line of sight propagation, and the effect of the noise component is very little in VHF regions. So this atmospheric noise is actually plays an important role below 30 megahertz, and above 30 megahertz we can neglect this particular type of noise. Now consider the solar noise. As the name suggests, this solar noise actually coming from the sun, and generally for under normal condition, the amount of signal emitted by the sun is almost constant, and it is a large heated body, hot body at very high temperature. So therefore it radiates over a very broad frequency spectrum, and that includes frequencies we use for communication. But the disturbances in the sun is variable and undergoes cycles, of the peak of which electrical disturbances erupt. So on regular basis, sometimes on irregular basis, the disturbances on sun changes. That means the power output of sun, or the power received, solar power received by earth from sun varies time to time. It is not exactly constant. It depends on various factors. These additional disturbances are several orders of magnitude greater than the noise generated during periods of quiet sun. Under normal condition, we receive some noise, but in some abnormal situation, we will receive much more amount of noise power compared to the quiet condition. The solar cycle repeats this period of great electrical disturbance approximately every 11 years. Thus, the noise generated by sun changes periodically with the solar disturbances. So, solar noise actually, range of solar noise is whatever may be the kind of communication system we are using. It ranges, the solar noise is present almost in all the communication system. Now consider the cosmic noise. Cosmic noise is the source of cosmic noise is again the distant star. These are the sources except sun. So this stars is also a heat body that radiates signal spreading a wide range of frequencies. The noise received from such stars is also called the black body noise and is distributed fairly uniformly over the entire sky. Now space noise is observable in the range from 8 megahertz to 1.4 gigahertz. So this is the strongest component of noise in the range of noise is available in this range, but the strongest component is present from 20 to 120 megahertz. So this is the range over which we have the strongest component of this noise.